Hi, welcome to another video on my pneumatic hand robotic arm with pivot gear and arm gear with compressor and controller. Last time I constructed the wrist motor, and the problem that I faced and still am facing is that the wires that need to be connected to the motor and the controller have too little space between the elbow and the motor. So what I need to do now is reconstruct the elbow wrist, the elbow construction, where this is going to be here and this is going to be put inside it, and I will do so by removing this and having the arm rest on the base of the elbow here. And I hope that will go fine, because there is a big risk of it that it slides down. So I have to be really careful, and of course I need to do that on both sides. So first let me try to remove this, and usually for this kind of construction you need more than two hands, but I'll have to do this. So I just remove the motor in case that it slides off. Then let me just try to remove this, see how this works out. And there it goes. Now this needs to be moved here, and this one right here. Taking this one and this one off. So this will be right here. This looks smooth enough. So now for the other side. Let's hope that goes equally as smooth. Should be. So that is one. Moving the connecting parts again, taking these side parts off and slide the red parts in. Alright, that looked easy enough. So that is one thing. And now if I put this let's say right here, you can see now that there is plenty of space here. So I can move the wire in here instead of making it quite difficult for myself to move it in here. I can do it in here and then through the arm, through the base to the controller. So next step, finding a wire that is long enough. So with this very long wire, the question is, how will it run? First, well, is the motor here. I've taken it off for now, obviously. Here it will be, then inside the arm, right down, exit, make a loop, and then go to the controller. So you need quite some length. And because it is in one piece, there's little room for failure, little space for failure, which is only good. And the downside is that because of the planned switch that will have to be here to make sure that it doesn't go too far one side and too far the other side, I need another wire. And last time I was thinking about this switch or the bipolar switch, such as with the pivot gear. Yeah, that is going to be another question, because with this switch I will only need one wire, and obviously with the pivot switch, and I will show you, that is this switch here, you obviously need two separate wires to connect it. So with that said, let me guide the wire through everything, and then I can connect it, because to get it through the arm with connectors attached to it is not as easy. So that is next. Okay, so the wire has been put through the entire robot, and for a few reasons, amongst one which is the lighting, I have decided to put the motor on the other side of the arm. So as you can see, the motor is back again, and a part of the wire is already stripped. What I need to do now is to attach the connectors. And of course I have to keep in mind which side it will be put on. So this will be the red one. And the green one. And then the big question is, will the connectors run free from the elbow? So, oops, I'm not touch the tripod. Will everything run? And I have to get it out for a moment. And this is not a good sign. Not a good sign at all. I have to get it back inside. Ouch. This is difficult. So let's try again. And now everything is in place. And with the wire constructed, it looks very narrow, and narrow it is. So if I pull the wire back a little, this is well a very near miss. It works, but then really the wire has to be like this. If it gets pulled in, you have a problem. So and if this doesn't work out, I do have to do another reconstruction, putting this on top. Will this have consequences for the wiring? Not quite sure, but given the fact that this is the only construction of this kind of motor that will work, and this motor didn't work out because this little gearbox was pushed out. It is pushed out rather easily, so I have to do with this motor. And even this motor is easily pushed out if the force is too much, too large. As you can see, there's not much force needed, not much strength needed to push it out, so even that I have to take care of somehow. Anyway, for testing I need both ends wired, so let me blank these parts. And I'll show you how I do that. Just like that. And then put oops. And then put some connectors on it. And that will go right there on the red extension box. Yep. So let's do that. And with the other side of the wire connected as well, they are going into motor 3, which by the way will be for the software motor 7. So one part and the other. And with that connected, now I cannot use the power controller, but I have to do it with software. And that's going to be a challenge because there is no switch installed yet. And whether it be this one or that one, the bipolar switch, that's a good question. But first First, I think it is time to run the motor and see if it works by software and by diagnostic software. Both are equally important. So let's go there. So with the diagnostics interface started, I have to open the interface. And it is the only interface I can open now. I put the wire into the red extension, which is the slave. And on the slave it is 3. So now all I have to do is for one direction. Ooh, and that goes very fast on a very low speed. So let me go the other way. Ooh. Oh, it does work, but the way I could control it using the power controller is much smoother than with this, because this has only 8 speeds. And what I was afraid of is that I should use the same kind of motor as I am using for the arm pivot, which is 125 to 1, and this is a much different ratio. It does run on 1, but very, very fast. And I don't like this. Not really. I want to have it just turn slow and really controlled. And this is 1 speed. These are 8, and on 1 it already goes pretty fast. So that makes me wonder, given the experience I have with the pivot switch, if that will work with an ordinary switch. I will show you on camera. So now I show you and mind this. It will how fast it runs, and I'm just putting it on the first speed. And even that does not go very smooth, because when the force is too large it goes shaking. So and it already has shaken away from its mounting point. So that shows how fast it is, and as I already said, I don't like this speed at all. If I take it off, this has a ratio of 20 to 1, which is completely different from 150 to 1. I better should use, actually, this is not, no, I have to put it like this. I better should use a 50 to 1, but those are all in use, I'm afraid. So it's either one like this, the 125, or one like this, and then very much controlled speed. But time will tell. And now back to programming actually. In this final part of the video, I close the interface. And I can just as well shut it down. Then let me go to the software, and this is how I run it. But before running it, I have to put the motor into the software. So this is on motor 1. This is motor 5. And this is motor 6, the pivot motor. So what comes next is somehow an else if what? Well, for now actually nothing, but I will say no, not digital 12. Will it be digital 12? I doubt it. There are inputs on the extension, and as there are 8 inputs on the controller which count through for the software, 8 plus 3 makes 11. And this is 11 but it is switching, and that is a bit confusing. This is switching the motor directly, the pivot motor, so it is not really an input anymore. So 11 would have to go. Apart from this is not doing anything for the motor anymore, so I can skip this actually. That is a very good point. I can skip this, and I can use input 11 or 10 even. No, not 10. 10 is already used, but 11 I can use for that motor, and that is motor, as I said, motor 7. One direction or the other. And then this is not the pivot direction anymore. This is the wrist direction. Oops. And this is all depending on how accurate the switch is working. How does it work? Anyway, I cannot test it now because I don't have a switch on it. But from the diagnostics you have seen how controllable or not controllable it actually is. So for now, thank you for watching. It's been quite an experience this time. how's the wires, or how is the wire connected? Does it have room enough, space enough? The wire itself is long enough. It's on the motor output. Switch yet to be done. But what kind of switch should I use? Alright, all for next time. Please consider to support my blog and video by allowing advertisements or using PayPal. And this is to be continued. Bye bye.